Welcome back, everyone. So now we are continuing from Unit 1, Lesson 1. This is Example 2 now, and we are being asked about how to decide whether a relation is a function or not, and then stating domain and range. So hopefully you remember from grade 11 the vertical line test. Vertical line test is very straightforward. It just means that I can take a vertical line and graph it and see how many points of intersection does your function have with that vertical line. And we can draw this vertical line at any point on the graph. And it doesn't have to be exactly on the line. It could be in the middle. Remember, it's just vertical lines determining points of intersection. So if your relation intersects any vertical line more than once, then it is not a function. If it passes the vertical line test, then by definition, it is a function. So this graph, for example, A, you can clearly see that the function in blue only intersects each vertical line at one point. So therefore, this passes the vertical line test. It is a function. So yes, to function. So is it a function? Yes. Now, what about domain and range? Well, domain and range have to deal with possible x values and possible y values. For x, we're looking at our horizontal kind of line here that stretches left and stretches right. And what I tell my students is that ask yourselves a few simple questions. Looking at this function, does this function go all the way to the left? What do I mean by go all the way to the left? I mean, does it continue all the way to the left? And because there is this arrow here, that means this function does indeed continue all the way to the left. So that is yes. Does this function go all the way to the right? Well, let's take a look at this endpoint here. And there is an arrow here, and it's pointing upwards, but it's actually a little bit, on a diagonal. So it's pointing up and to the right. And since this goes on all the way to infinity, it just continues on forever, this function is also going to go all the way to the right. So since this function continues all the way to the left, all the way to the right, the domain is very simply x belongs to all the real numbers. And that's it. What about range? For range, we do the exact same thing. We ask ourselves, well, does the function go all the way up? And clearly, you can see that there's an arrow pointing up. So yes, this function does go all the way up. Now, does this function go all the way down? Now, this arrow here, is this pointing even slightly down? And if you know anything about these functions from grade 11, you know that there's actually a horizontal asymptote here, meaning this function will never go below that point. So this function does not go all the way down, but it does go all the way up. So what does that mean for our possible y values? Well, we know that y has to be real numbers such that y has to be bigger than a point. And what point does it have to be bigger than? And it has to do with the horizontal asymptote, which, if you can see, is at -2. So y has to be bigger than -2. And a lot of students are tempted to sometimes have that bigger than equal sign there. Just understand that equal sign is only there if it's possible for y to be that value. Is it possible for y to be -2? And in this specific example, since there's a horizontal asymptote at -2, that means y can never actually be -2. It can get infinitely close to -2. It can be -1.9999999 and so on, but it will never actually be -2. So you cannot have that equal sign in this example here. And that is the domain and that is the range for example 2a. Let's move on to example B. Now, is this a function? When you're given an equation, the easiest way I would say is to just take a look at your y value. And most likely, if it's to the power of 1, then the equation is most likely going to be a function. So in this case, yes, it is a function. And it doesn't really matter for the x. Like x can be cubed, square rooted, like almost anything. It's mainly the y that we're looking at. So if your y has an exponent of 1, most likely, yes, it is a function. And for domain and range, how do we determine domain and range for an equation like this? Well, domain and range are limits on values for x and y, right? So in this case, we have a rational expression, meaning my variable is in the denominator. And we know that when something is in the denominator, there are something called restrictions. And from grade 11, hopefully remember that in this case, x cannot equal 0. Why? Because you can't divide by 0. Remember, 1 divided by 0 breaks the world. So x cannot be 0. Are there any other values that x cannot be? And in this case, there's only one restriction, x cannot equal 0. Now, because of that, x cannot equal 0, that means there has to be a restriction on y as well. What value can y never be? Well, let's see. Y, because x can be anything but 0, right? So y cannot be, in this case, also 0. There's no possible way for y to be 0. Because if I were to sub in a value of 1 for x, that's 1 divided by 1, y can be 1. If I plugged in a value of 2, then it'd be 1 over 4, y can be 0.25. And I can plug in decimal values for x, any value, and y can be any number. But y cannot be 0 because x cannot be 0. There's no possible way for me to, make that 0. So yeah, so that's it. Those are your restrictions, and that has to do with domain and range as well. So domain would just be x is every single real possible number such that x cannot equal 0, and then y is every possible real number such that y cannot equal 0. And those are my domain and range for that function there. For C, the left-hand side is almost always your x values or your domain, and your right-hand side is your y or your range. And here we have -2, -1, 0, 1, 2, and you can see what's happening. You have a point -2 and 0, you have a point -1 and 1, you have a point 0 and 1, point 1 and 2, and point 2 and 3. Because there aren't multiple lines coming from the same value, like for example, if I had a line like that, let's say from -2 there were 2 lines coming out, that would be an example of repeating x values. And if you remember from grade 11, when it comes to functions, you cannot have repeating x values. So in this case, since there are no repeating x values, this is a function because each individual x value has a y value, and the y values can repeat. That doesn't really matter. And then the domain and range for this specific function. See, this is not an equation. This is not a continuous function. This is something that's discrete, meaning it's made up of points. So your domain is also going to be just values. -1, sorry, -2, -1, 0, 1, 2. And that's it. 5 points. And your range, in this case, is also going to be made up of values 0, 1, 2, 3. 0, 1, 2, 3. And there we have it. Domain and range.